Yo, yo, yo.
Hey, CJ.
Not gonna lie, I could have saved.
Good afternoon.
Hello. Hi, everyone. Give me a sec here. We're going to get started. Happy to see you all here. Well, virtually. All right. Oy. Welcome, y'all. Hope y'all had a, good break here. This past lunchtime. Welcome. It is Wednesday. So fast this time. Oh, let me just let in a few more folks. All right, y'all. Let's jump into this check-in question. I love this check-in question because I think we all have this. But what is something you do that might annoy some people? Think about something like that. You can even think about like if you have siblings, what's something you do that might annoy your siblings or anything. I could go ahead and share mine as y'all are thinking. So for sure, I know mine. When I would be in college, I would actually have to make sure I'm sitting in a seat that no one's around me. Reason for that is because I'm actually a leg shaker, and I know that bothers a lot of people. And I try my best. Like I can't control it, to be honest. When I sit, sometimes my leg just starts, moving. So I just try to like sit far away from people so I could comfortably do that. So that's one of mine. Let's see what you all are thinking about as I check our attendance here. Let's see. Exists. Oh my gosh. Sleep with the door open, some lights on. Yeah, that would totally annoy people. I think I do like a slight bit of light. And yeah, lots of people like it pitch dark. I'm loud sometimes. I make people repeat themselves. That's me too. Oh my goodness. Because I'm a daydreamer too. Bad attitudes out of nowhere. Yeah, yeah. I throw a football up and down in order to help me immerse myself in music sometimes. Oh, that one's very unique. For my siblings, it's just my presence in general. For people, it's also the leg shake. Yeah, another leg shaker, right? Asking a lot of questions, asking heck of questions, and really boisterous. Well, I have to look that one up. I probably should know this from high school, that word.
Are we going to take notes today?
Depends. I mean, depends. Uh, I don't know. We're gonna do a Google form. We're gonna kind of recap. Yes, actually a little bit. Yes, we are doing a little bit, like 2 slides or 3. So yes, definitely open up your slides if you haven't yet, y'all. But okay, let me look. Oh, boisterous, noisy, energetic, and cheerful. Oh, I love boisterous people. I'm looking up new vocabulary because of y'all. All right, I'm really good at ignoring people, and sometimes I'm loud. Sometimes don't pay attention to a conversation. Same. Oh my gosh. That when someone asks me to do something, I don't do it, or I do it and it's late and I messed it up. Yeah, it's all right. Eat all the food. Oh yeah, I think that's something my siblings would do, and I'd get annoyed. But that's sibling stuff. All right, all right. Let me just make sure I'm capturing who we have here. And we have nothing really. That's cool. Must be very pleasant to be around, doesn't, you know. Some people even say some might be bothered when someone's too quiet. I don't know if any of you get that. Sometimes I'm not usually a talkative person, so some people might get bothered if I'm just sitting there just enjoying the time, not really my space. I like just sitting there, you know. Sometimes don't have to talk. But some people don't like that. Some people like to, talk. And that's okay too. That's why we're all different. All right, y'all. Let me go ahead and see who we're missing. And y'all can correct me if I'm wrong. But okay, I think I'm missing Risha. Wow, yeah. Congrats. Yeah, sorry about college acceptances. Congratulations. That is really great. I'm so happy. Wow. So great to hear this. Sorry, so I'm missing Risha, I'm missing Carlos, and I'm missing Denise and Jalen Baker. Again, let me know if there's any error in that. I'm going to go ahead and update this attendance. Thank you all for sharing. Something you do that might annoy other people. Again, it's okay. We all have that. And it's normal. That's part of being different. I got you. Yeah, thank you. You're here. All right. Let's go ahead and get started. So here is our agenda, everybody. We just took attendance, and we're going to be wrapping up that discussion we had about something called the instantaneous rate of change that we started talking about yesterday. Sorry, we're not going to start analyzing the mini final just yet. We're actually going to do an activity with the big ideas packet. So let me just make sure I change this activity with big ideas. And then we'll see if we have time for taking a look at that. It is posted though, everyone. So the mini final is already posted. You could check it out. The first draft, your first attempt of it will be due Friday midnight. So Friday midnight, not Thursday. I remember I pushed back that due date. So we're going to do Friday. There we go. Let me see. Does anyone have any questions about that stuff that's coming up or anything like that? Let me know, or anything about today's agenda. Welcome. All right, cool. Let's go ahead and let's jump on in. So first things first, do make sure, yes, you want to, yeah, I see 2 people there. Do open up today's slides, right? They're on Google Classroom. So you just go on Google Classroom. You'll see the one where it says day 8. These are the slides that we're looking at today. You can make your own copy and follow along as, we talk and we refresh about what we talked about yesterday. So go ahead and do that. And let me just hit my present here. All right, I hope you all had some time to go ahead and head to Google Classroom and open up the slides. Let's go ahead and begin first by recapping our stuff. So what did we learn? So recap, we learned we learned something about instantaneous rate of change. And the best example I thought of to explain what this is kind of like when you're driving and you're looking at this. This is called the speedometer, and it tells you how fast you're going at that particular instant. So this makes it so it's not an average change. So when you're doing an average change, you're like finding different intervals, like, oh, between 1 and 2 minutes, and then you're gonna have to plug it into that slope formula, and then you calculate. So this is actually an instant rate of change. Not only that, but we talked about yesterday how we can approximate the instant rate of change. So what I'd like us to do is, I'm going to go ahead and put this Padlet here into the chat so you could review, but I'm going to open it up with you. So we're not going to answer anything yet on there. This is just for you to open up and to review what we did yesterday. So again, this is me recapping right now on what we did. And again, this is our running Padlet. So you could totally take a look at all the like reflective questions you answered and your thoughts. But I'm going to go ahead and take us to yesterday's. So first I asked you all, what can we do to figure out how fast a ball is going if we're given its like motion and its graph like this, where its height is in meters, time is in seconds, if you see the labelings right here, right? And then a lot of you mentioned slope. A lot of you mentioned some physics formula. A lot of you mentioned distance over time. That was the most mentioned. And all of those were correct. The key idea here is, yes, we're using slope. We're using distance over time. Those are synonymous to find the speed or velocity of a moving object. The next thing is we talked about how we can approximate the instant rate of change. So our goal was we tried to find how fast this ball, because this was a ball being thrown, how fast the ball was going at exactly 2 seconds. So in this last picture right here, you notice how this second point got moved closer to that first point that we were interested in. So this green point got moved closer, closer, and then even closer. And from there, this last photo would give us the best approximation for the instant rate of change at exactly 2 seconds. In this case, it would be negative 7.9 meters per second. So not forgetting your units, I just couldn't fit it here. And I think one of you said you would say it would be around negative 8 meters per second if you were to continue that trend of moving the point even closer to this 2,6. So that's what we did yesterday. And you all can go ahead and reflect on what you all said here when you rephrased your understanding. Again, many of these were really good. And you also were taking a look at how the secant line, so I forgot to mention that, but the secant line was changing over time. So a lot of you mentioned that this secant line was basically kind of like becoming the slope of the graph. I really like the word that some of you used. And that's exactly what's happening. We're kind of finding exactly what that slope is at that point, and that's why it gives us an instant rate of change. So that's just, recap, and y'all can go ahead and look back at what you all thought, what you said. That line that was getting steeper, it's becoming more vertical, and so forth. Okay. All right, cool. So again, yeah, you could also go back to what you thought as well. Oh yeah, this was column number 11 were initial thoughts on what we could do to find an instant rate of change, and then we finally how we do it. So I'm gonna go ahead and take us back to our slide. So again, I was just reviewing on the Padlet, and we're gonna continue now our discussion about this, how to find the instant rate of change, and why is it that we just have to take a point and move it closer to the other. So we're gonna go to slide number 5. Yeah, slide number 5. Oh, okay. That's okay if the links weren't showing up in the chat. Don't worry. We're not going to add anything to the Padlet today. So don't worry. That was just for us to review. So no problem. For some of us, the link didn't work. Okay, so now we're going to go ahead and talk about this. So I kept talking about how in order to estimate change, all you got to do is to move the points closer to each other. A question has arise, whereas why can't we just put the 2 points right on top of each other? For example, why don't we just have 2,6, 2,6, like they're just right on top of each other, and then we find the slope, and won't that tell us the instant rate of change? Or won't that tell us exactly how fast that ball was going after 2 seconds? Let's investigate what happens if we do this. So if we do this, first off, we know we need the slope formula to find either speed or velocity. And we know that we need a y1, y2, x1, x2. But because we only have 1 point, right? I put the points right on top of each other, like in this visual, there's no 2 points. That means this point has to be both x1, y1, And it also has to be x2, y2. It has to be both of them then. I mean, what other choice do we have if we only have 1 point? So wouldn't this give us the exact rate of instant rate of change instead of just estimate? Well, let's see. Let's go ahead and plug it in. So y2 minus y1, that's just going to be 6 minus 6 on top. And then because x2 and x1 are the same number, you're going to get 2 minus 2 in your denominator position. What you end up getting is 0 divided by 0, right? Now, I mean, I would like you all to try and see what you get on your phone, or if you're using Google, whatever, as a calculator. What do you get when you do 0 divided by 0? Let me know in the chat. If you get something similar or different to what I'm getting, what do you get when you do 0 divided by 0? All right, so Daniel says error. Did anyone get anything different? I went ahead and did it on my phone. This is what my phone told me as well. So similar to what Daniel got, error. Gerardo also got the same thing. If you were in my class and we were using the calculators that are in there, man, I hope they're still in there. I like those up. But anyways, if you were in my class, I think the calculator would give you something like error, and then it would say div by 0 or something like that. Basically, it's saying division by 0. Yeah, so we're getting an error here, and there's a reason for that, why this ends up not working. We can't actually divide by 0. That's actually a mathematical fact. There's like a lot of YouTube videos on that, by the way. Like, if you're interested, you could take a look, but you can't divide by 0. That's when the 0 is in your denominator position. You can't have that. You're always going to get an error. You could literally test this out on your phone or anything. Again, it's a nice thing to investigate. Hey, maybe some extra credit opportunity to type up some investigation on that. Hey, if you're interested. But yeah, you can't divide by 0. And for this reason is why we can't just put the 2 points on top of each other. So we have to actually just move the points infinitely closer to get a best estimate. That's what we're going to be doing when we're trying to find the instant rate of change. So that's the why we can't do this, because we're going to get an error. So that's super, important to think about. Let me know if anyone has questions right here about this portion. All right, awesome. No questions? Let us move on then. Thanks so much for your engagement, those who checked in their calculator to see what you got. But yeah, that's why we can't do that. So now, y'all, we're going to go into a part that you've probably seen in the textbook, and it's important for you to have the exposure to this. And let me also prep you all. We're gonna have a Google form that's gonna come up right after I finish these last 2 slides. We're gonna have a Google form. You want to pay attention, so just heads up, because I definitely want to see what you're understanding, what you're not, all of that. It's not about being right. It's about sharing your thinking with me is what I'm really concerned about. All right, so we're gonna try to kind of formalize this. So we're going to rename our coordinate points. And what I mean by formalize is I'm trying to generalize this for any 2 points, not just 1,9, not just 2,6, for any points on any function. So I'm just going to rename my points. This one, this green point, I'm going to call x comma f of x. It's like x comma y. F of x is just a formal way to write y. It's a function. So that's that. I renamed that first one. So if this is x comma f of x, what in the world would this be? Now, this point right here is shifted by like a horizontal unit that I don't know what it is. Let's call that horizontal unit. See this arrow down here? Let's call that h. Let's say it moved h units to the right. Yeah, to the right. If that's the case, then we can rename the second point to be this. X plus h, because it moved over plus h, comma f of x plus h, because that's the thing you're going to plug in to get your y. Let's see that. Let's see, does anyone have questions about this? So right now, all I did is I renamed them to just make this applicable to any 2 points for any function, because we're going to create a formula right now. So let's see if anyone has questions. All right, let's see, there's something in the chat. What does H represent? Yay, thank you for asking that question. H represents the horizontal distance that the second point is away from the first point. It's a good question. Let me type that out too, the answer to the question. H represents the horizontal, like side to side, horizontal distance the second point is from the first point. And then we have, why do you add H? So we add H because we have 2 separate points. The first point is pretty straightforward, like, hey, let's call the first point x comma f of x. So if I need to define the second point and I need to make it related to how I define the first one, that's why I'm adding H. So I could define a second point. So that was a question. So why am I adding H? We are adding H to define the second point. Second point in a general way is my best way to kind of say general function notation format. And let me move this up. Let me move it right here. Here's some answers to some questions there. Again, so first question was, what does H represent? H represents the horizontal distance, and it's down here if you see this arrow. The horizontal distance at the blue point is away from the green point. And then another question was like, well, why are we even adding H? We're adding H because first off, we define the first point as x comma f of x. To define the second point that's related to how we define the first one, we needed to add H. So, and then here's my answer. In order to define that second point, we needed to kind of include this horizontal distance away from the first point. These are really great questions. Any other questions so far about how I renamed these points? I love those questions. It was awesome. This is actually, so just so you know, this is touching into calculus. We're in pre-calculus right now, but this is touching into the theorems that arise in calculus. All right. All right, y'all. So according to finding the speed or velocity, we know that we need to just plug into a slope formula. Remember, y'all? So that's just the thing we've been doing recently, right? Oops. Let me not pop that up yet. So that one looks scary, but let me first do the things. Okay, so imagine I want to find the speed of whatever this thing that's moving between these 2 points. Well, we know that all we got to do is first off label our points. So we're going to do x1, y1. And this one's going to be x2, y2. So we're going to try to create like a general formula for the speed using 2 points. So then we know that we're going to plug into the formula y2 minus y1 all over x2 minus x1. And we're going to go ahead and just plug in these values. So it's going to be y2, so this thing, minus y1 all over this thing over x. And that's where this funky looking formula is coming from. You see that? See how it's y2 minus y1. Then you have x2 minus x1. So y1, y2 right here. We got minus y1. Then we got this part was x2. And then we have minus x1. Now, let's see, does anyone have questions about this funky looking expression? Because all we did is this is actually representing the slope of 2 points. We're trying to connect the slope with speed and or velocity. Let's see if there's questions.
So wouldn't it just equal h over h?
Wouldn't it just equal h over h?
It
That was a
was.
good question. So basically, I think I see what you did here. You did like f of x minus f of x, right? On the top to get h. And then at the bottom, you did x minus x. Is that correct?
Yeah.
Okay. So the bottom part, you're right on. You're spot on. Now the top part, here's the problem. We can't just take the f of x out. This is kind of like stuck. You can't just, you can't say, okay, f of x, and then you're left over with h. This has to be stuck. We can't just pull out the inputs of this expression, if that makes sense. It's kind of stuck. This right here, we can't change. So it's not going to become like f of x, and then you have plus h. Good question, though. Good, and I like how you already simplified the bottom. I'm going to show you all what this simplifies to, though, in a second. Any other questions, though, about the setup in general? All right. Let me just, let me erase some of this just because it's going to get in the way of what I did. But just so you know, all we're doing is a slope formula after we renamed our points. Now let's simplify. Now, again, we already talked, I kind of verbally kind of explained why we can't just take the f of x out of here. There's no algebraic way we can do that. This has to stay. But y'all, let's look at the bottom here. The bottom here is kind of free. There's no f of whatever trapping any variables or inputs. What is something we could cancel out here? And I know Danny, you already kind of told us what you got, but what cancels out here only in the denominator position? We're just looking down here. What's something that cancels out or goes away? So let's see. Yeah. Yes, I have three people in direct message who are all saying X. You are all correct. Yeah, y'all can see that. Let me just show you. So X minus X, that is something you can cancel out because X minus X is simply 0. Again, we can't do anything with the top, but let's go ahead and show you what that looks like. This funky looking expression simplifies to, boom. This is the general average rate of change formula, everybody. It's just a general one you would see in a college textbooks. But all it is, y'all, all it is your slope formula. That's all it is. Like if you see it, don't get afraid. This is literally synonymous to that. Just written in a general way for any 2 points. But that's all it is. And again, let me write this out. This is the average rate of change formula, AKA slope. And then one more slide and then we're gonna have our Google form. Again, it's very great how I'm seeing a lot of questions coming up, a lot of interaction with what's going on here. Let's see, is there any questions about this last part? So this is all on this side and then we're gonna do the next slide. All right, let's see, there's something in the chat. And then Alexander said, oh, sorry. Sorry, is that the answer? That's the answer for this slide. So that right here is what we were trying to come up with, is just the average rate of change formula. That is the answer. For this slide. So this is the average rate of change formula. In the next slide, I'm going to show you how we're going to look at what is the instant rate of change formula, right? So we're using the average rate of change formula to define the instant. Remember, average means it's like 2 points that are far apart. You're trying to find, like, on average, how fast am I going? We don't want to care about on average. We want to find out at this instant, how fast am I going? That's when we're going to be using limits, and or that's when we're moving the 2 points closer and closer together, like we did on the we saw on the Padlet when we reviewed. All right, let me go ahead and clear the screen. If there's no more questions, unless there's a burning question. Again, this is on Google Forms, so it's good to ask your questions. We got one more slide and then we're gonna do Google Form. And after that, we're gonna do one last activity. All right, friends, let me go ahead and let's go to the next slide. And I'm sorry that it's all just here, but here we go. This is the instant rate of change formula, aka definition. This is it. So notice how the formula basically has the average rate of change formula. This is the average rate of change formula, the one that we just constructed. This is simply the average rate of change formula. Except it has a limit in front of it. Notice how the limit is saying as h goes to 0. This h going to 0 means the horizontal distance is becoming 0, or basically the distance between the points is going away. This limit is basically representing the 2 points moving closer and closer together. That's what we were doing on the Padlet yesterday, and we were investigating how to estimate the instant rate of change. This is it. This is the definition. And on your Google form, I believe I'm going to ask you to interpret some parts of these. So again, I call this first one the point of interest y value. That point that's not moving, it's just your second y value point. This one's just, or whatever. So point of interest y value, the one that's not moving, and the other y value, and I called this one the second one. This h, remember, that was the horizontal distance between the 2 points, and the limit right here represents the 2 points getting closer and closer together. So this formula has a lot of information. This class, you won't be asked to calculate using this formula. What you will be asked to do in your mini final is to estimate instantaneous rate of change, which we could do because we know that concept of moving 2 points closer to each other. That's what you're going to be doing in our mini final. Also, last thing, this instant rate of change formula in calculus has a specific name. It's called the derivative. I don't know if you've seen that word, or maybe you know people who are in AP calculus right now who have heard that word so many times, they're probably tired of it. But this is the formal definition of instantaneous rate of change. And that's synonymous to the derivative. Again, this is in your big ideas packet. So maybe some of you, when you annotated that, got a little freaked out when you saw this formula. All right, now I'm gonna pause for questions about this slide. So this is for instant rate of change. Let's see if there's questions. And if not, then for those of you who are ready, you could just go to the next slide on your slides, and you could start the Google form if you're ready. But everyone else, I'm just pausing here to see if we have any questions about this, because you're going to be asked a question about the formula or where something came from in this formula. All right, do you think we're ready? Ready for that Google form? Okay, Google form will be for credit, y'all. Please make sure you do it. If I am missing a Google form, I'm going to send an email. I just sent an auto email for those who are missing it. Let me go ahead and just make sure I put this in the chat. For those who are unable to access links in the chat for whatever reason, just go to our slides from today, day 8, and go to slide 8. Is this going to be a recording on Classroom? I could send it on Remind. I could link it on Classroom if it's helpful. Yeah, I could send it on Remind and upload this video. Again, I could also post it, but let me show you all how the Google form looks like before we, get started. You're gonna be asked for your email address. I'm gonna ask you in your own words, how can we approximate the instant rate of change? For that one, I do recommend looking at slides day 7 from yesterday. I do recommend looking at slides day 7, or you could look at your big ideas packet. Those are two different things you could look at to kind of finalize your answer. For this one, I said, explain in your own words, why do we need the limit in this expression to define the instantaneous rate of change? So why in the world do we need this limit? Again, that's going to be today's slides. Does anyone have any questions before starting on this? All right. If we don't have any questions, let's go ahead and have, now I didn't set a timer, but I could just do it on my phone. Let me see. I mean, I could search up on YouTube a timer for us. I could do that. Thought I set a timer. Okay, I'm gonna do, let's do an 8-minute timer and then we'll check in. I'll see how much, how many I got. All right, I'm gonna also put the directions. Sorry, let me stop this. I'll start it once I put the directions in the chat. Again, the directions are complete the form to the best of your ability. There we go. So again, directions, complete that form that I linked up in the Google Class in your chat, and it's also in our slides, to the best of your ability, even if you're uncertain. I just like you to submit your thinking, your best attempt on it. All right, everyone, I'm gonna start the timer. I'll be here. If you need me, use the chat. I'm gonna get myself some water right now, but I'll be right here. All right, let's begin, y'all. You got about 1 minute. So remember, we're going to be coming back to do one last activity before we exit out because we still got a good amount of time. So about 1 more minute, y'all. And again, don't worry about being right. Just try your best here. Let me see what you're thinking about what we're talking about today. All right, everyone. Welcome back. So again, go ahead and hit submit. And it's okay if you're not done. Let me just see what you have. You can even put didn't have enough time if you were in your train of thought. Just go ahead and submit what you got. That's okay. I do want to give everyone credit. Don't worry, we're gonna still, talk about this. How do I delete this thing in my screen? Clear drawings. Okay, there we go. Now we're gonna go ahead and transition into the last thing today. So tomorrow I'm gonna again rehash with you our big ideas. You could take a sneak peek here, but I'm gonna transition us into the last thing. Big ideas packet whole class annotation is actually the last part of our credit today. So we did our Google form. This is part 2 of today's credit. Why are we doing this? So you all are familiar about annotating your own ideas packet, right? We're now doing a whole class annotation. So we're gonna have a document where you all annotate on. And I'll make sure that I post this so that you all have access to go back. So the why. First off, everyone, you wanna make sure you familiarize and refamiliarize yourself with our resource packet and even perhaps get some meaningful insight from your peers. That's a major reason for that, because most of your knowledge and your learnings does not come from me. It does not come from your teachers. It comes from you discussing with your peers. And that's even scientifically proven. That's generally how we learn better. In addition, it empowers you because you have knowledge, not just teachers. You also have the knowledge, your peers have the knowledge. You are all resources. Here's how it's going to go. I'm going to be in a second putting it in the chat, the big ideas packet that we're all going to comment on. You all are going to comment. All you got to do is one comment. You're going to either comment a question or a rephrasing of the understanding. Or let's say you don't have any questions. What you could do is answer someone else's question as a comment. For today's credit, you just got to do one comment. Does anyone have questions about what we're about to do? Let's see if there's questions. We get the link while you are developing questions, making sure that you all are able to comment. It says can view. Yeah, let me see if the view version, if you all can comment. You should be able to, but let's see. I'm going to go ahead and put this. So this is the master copy. This is our class copy. I'm going to put this in the chat. And let's see if you have any questions. Let me first see if there's like bubbles popping up here, and then we'll see if. So again, let me go ahead and go back to the slide. Here's what we're doing. We're doing whole big ideas class annotation. The why is to familiarize ourselves with our resources and also to empower you as well as holders of knowledge. You only got to do one comment, a question or a rephrasing of your understanding, whichever, or you can answer someone else's question. Let's see what's in the chat. Is there any errors? And may I please send the link on Remind? Yeah, let me do that. Totally. Let's do it. Let's do it. Let's put it on Remind. So we're period 6. New announcement. This is what you're going to go ahead and add a comment to. Let's see. Good. I see 4 of us on here. And I'm just trying to see, are you all, those who are on there, are you able to make a comment? I'm just making sure. Because all you got to do is, for example, y'all, how you make a comment is you highlight what you want to comment on. And usually these 2 things pop up. You could click on the little comment box and you should be able to add a comment. Or you highlight and you could go up here to this little comment box. And then you, then you do a comment like so. So those are how you can do a comment. Okay, so it says view only. So y'all aren't able to comment on this. Yeah, I was anticipating that. I'm sorry, guys. So let me go ahead and let me change this to edit. I think that way you all will make a comment. Just don't edit the main juice. Don't edit the main information because then we're all gonna suffer. Let me put this back in the chat and I'm gonna resend it on Remind. Sorry, y'all. Let's go to this link. I put it in the chat. It should still take you to the same document, or refresh your page could be another way to do it. We'll go back to Remind. Sorry. There we go. All right, try that new one. And then let's see if comments can happen. Let me also refresh. And what we'll do is this is going to be basically our checkout. Again, you're either commenting a question or a rephrasing, or you're answering someone else's question. Any of those can work. Yay, okay, I'm seeing people getting started there. Again, here's the instructions. Let me just make sure we all have the instructions. Just one comment is what you got to do. If you're not logged into your Google, just put your name there so we know who you are and you could get your credit for today. I'm not able to copy and paste this into the chat. Yeah, I got the instructions in the chat, y'all. All right, so I'm seeing some comments starting up. It's a big ideas packet, so. And this is the new stuff we just did around big idea number 8. Great, more and more of us are on the document. Yay, we got a question down here. Let's see if anyone knows how to answer this. Is this how you find the limit is a question? Maybe someone knows the answer to that. That could count as your comment. All right, let me give you all some time to go ahead and write some comments. Again, this is for your checkout. This is for the end of today's credit. I'm excited to see the questions and responses coming up here. Awesome, I see 13 of us on here. Make sure you get on this document, put in your comment, y'all. Yay, we're getting more of us in this document. Hey, we got an answer. Awesome. Oh, I think we got a question or a comment. Yay, we got what does H represent? Let's see if anyone can answer that question. That's on big idea number 8. Remember, question, or you could comment an answer to a question if you'd like. Let me just make sure. Okay, good. It goes back. Ooh, look at this. This is a very good question. This is around big idea 8 again. Can the limit be a negative number? Good question. And if anyone knows the answer to those, feel free. Well, here's a rephrasing of the understanding. To find the instantaneous rate of change, just find the slope between the 2 points of the graph. Yes, that's literally what we're doing, except when it comes to instant rate of change, the slope is between two very close points. Awesome. Maybe someone can comment or ask a question about that. Cool. I'm noticing not much on limits unless some of you still need some time to finish up your comments on limits. All right, awesome. So what we can do is we could go ahead and open up with this tomorrow because I feel like, go ahead and finish. Hey, if you're almost done writing your comment, go ahead. What we could do is I'm going to open this back up with this tomorrow. You could finish your comment if you didn't get to finish, or you could look at the questions and things coming up. That should sound like a plan because I want to really protect your time. Y'all, thank you so much. I have office hours right now if you're interested. Just stay on back. Thank you, everyone, and see you. Comments again.
Mrs. Dano, I have a question.
Yeah, go ahead.
Do you have office hours tomorrow?
Tomorrow's Thursday. No, Thursday we don't have office hours. I have them today though.
All right.
And how we can find this in the classroom? It's asynchronous number 2. So this is asynchronous number 2. It's basically our big ideas packet. It's also on Remind, by the way. It's asynchronous number 2. Ooh, number 2.
Bye.
Bye, y'all. Thank you so much. But yeah, it should be the master copy, asynchronous number 2. Yes. Bye, Risha. Thank you. All right. Awesome. So, okay, for those who are staying for office hours, let me go ahead and just end this so I could upload this as a recording, and then I'm going to reopen it. So just join back in, okay? For those staying in office hours, I'm going to end this. I'm going to open this right now. Give me a second.